Imagine this: no delays, no decades of preparation, no waiting for futuristic tech. We decide today to send humans to Mars. What happens next? Can we really pull it off with the technology we have right now? Would the crew survive the journey, the landing, and what comes after? In this video, we're going to simulate what would happen if humanity launched a Mars mission today. Not 10 years from now, not in 2040, but right now. The results might surprise you or terrify you. The decision to launch is made. Today's spacecraft technology includes NASA's Space Launch System, SpaceX's Falcon Heavy, and possibly Starship. Out of all of them, Starship is the most promising due to its reusability and capacity, but Starship is still in testing. So if we were to go today, we'd likely rely on Falcon Heavy or SLS. However, neither has successfully sent a human to Mars. The SLS is designed for deep space, but it's still not rated for Mars surface missions. We'll go with Falcon Heavy. The journey to Mars takes about 6 to 9 months depending on the trajectory. During this time, the crew is exposed to extreme risks. Cosmic radiation. No spacecraft today offers sufficient radiation shielding. Long-term exposure could cause cancer or neurological damage. Psychological stress. Months in cramped quarters with limited communication can affect mental health. Microgravity, bone and muscle loss, cardiovascular changes, and vision problems are common after long exposure. Could we mitigate this? Partially. We can spin parts of the craft to simulate gravity or use water as shielding, but those systems are not fully tested for a real Mars mission. Now we face the biggest hurdle: entry, descent, and landing on Mars. Mars has just enough atmosphere to create heat during entry, but not enough to slow a heavy spacecraft like it would on Earth. Parachutes alone aren't enough. Current tech solutions include supersonic retropropulsion, used by SpaceX on Falcon 9, and skycrane systems, used by the Curiosity and Perseverance rovers. But here's the twist. No one has ever landed a human-sized payload on Mars. Trying to do it today means risking the entire crew. The spacecraft must slow from 20,000 kilometers per hour to zero in a thin atmosphere with no margin for error. If it works, we stick the landing. If it doesn't, it's a total loss. Let's assume we stick the landing. Now the real challenge begins. Surviving on Mars. The average temperature? Minus 63 degrees Celsius. Atmosphere? 95% carbon dioxide. Water? Limited, trapped in ice. Habitat modules must be pre-delivered or carried on board. We'd need to generate oxygen using MOXIE-type technology, melt ice for water, and grow food in hydroponic systems. Power would come from solar panels or nuclear RTGs, but dust storms could block the sun for weeks. And don't forget the psychological toll. There's no rescue mission. You're stuck, maybe for years, until another crew arrives. A return trip to Earth is not guaranteed. We'd need a rocket capable of launching from Mars's surface, like SpaceX's planned Starship, and fuel made on Mars via in situ resource utilization, extracting methane from local carbon dioxide and water. But ISRU has never been tested on Mars. Without it, you're not coming back. A one-way mission is possible, but morally and politically controversial. So what would happen if we tried to land on Mars today? Best case scenario. We launch during a good window, survive the journey, stick the landing, and establish a basic but functional outpost. The crew becomes the first humans on another planet. Worst case, launch failure, radiation sickness, EDL crash, life support failure, no return. The truth is, we're close, but not ready. A Mars landing today is like asking 1960s NASA to land on the moon with 1940s tech. The dream is real, but it needs a bit more time. Still, imagining it helps us push boundaries. Would you volunteer for a one-way trip to Mars knowing the risks? Let us know in the comments. For more videos like this, visit and subscribe to Knowledge Hub.